Hello, thanks for coming. So the way that I tend to do presentations, make sure everybody can see. It's as much participation as you guys want to have, the more we'll go down one avenue or another. So I think we have people from all different usage spectrums of JavaScript and TypeScript, people who've used it for years, other people who have never used it, some people are just interested in JavaScript. So there are different dimensions of this talk that could be more or less accessible depending on your usage. We could go into either. So if you're just interested in using JavaScript or TypeScript, maybe you'll be interested in how we use the workers ecosystem in Cloudflare to distribute a web app. If you're interested in the deep downs inside of TypeScript, ask more questions and we get to the slides that where it's put together in the architecture described. There's only 8 slides, so it's not long. The talk is TypeScript Programming at the Edge of the Internet, Workers KV. So Workers is a Cloudflare product that was introduced, announced 2 years ago. And what it is it's a edge computing model where a JavaScript isolate is spun up in response to a web request. So when someone makes a request, computing instance is spun up. It's similar to serverless and Lambda is an analogy, but the startup time for an isolate is about 5 milliseconds as opposed to several hundred milliseconds for a Lambda. And in addition to that, our overhead is much lower. Recently, one of our customers was advocating isolates because it's more green, it's more energy efficient. We hadn't thought of that before, but I'm sure marketing would be all over that. People have historically been concerned with machine sharing and security protection, so build it into the hardware, but isolates actually run in the same process. So why do we think this is at all reasonable from a security perspective? So we run on top of D8, which is the JavaScript processing engine that runs inside of Chrome. So it has very heavy usage across the world. Security bugs are found and fixed immediately. And we deploy security fixes within hours for critical issues or daily, which is a lot faster than Chrome itself would update. So in addition to that, we have protection such that the process that D8 runs in is chrooted. It has a system call barriers, so it's highly insulated from the rest of the system. We didn't go to the full step of running it inside of isolated VM on our edge, but so these are our colo locations. If you're curious about how they talk to each other and efficiently, Nick and the Argo team would be a great resource. They've built in a fantastic system to efficiently get data between all of the colos. It's very cool. What the workers code does and what KV does is runs within a POP. So as soon as you get a request to any of our colos, you can run the code within a few milliseconds of anybody in the world. Does anybody have any questions about what our workers product and platform is?
What are people building on Workers?
Very good question. One of the very important use cases that is being built on top of Workers is A/B testing. So Optimizely is one of our customers. Historically, A/B testing is very difficult because it introduces a lot of latency to decide when to do A, B, what you serve. Workers allow that to be decided very close to the edge, but outside of the browser. So you can do A/B testing very effectively and redirect all those resources. Firewall events, logging, content transforms. There's a huge spectrum of, Spectrum is a different product. There is a huge variety of use cases for workers. So lots of people are picking it up. Serverless application or web pages. So I have a lot of websites that are hosted that are just JavaScript that's uploaded and it serves content. So it serves directly from the edge. So I'll show you an example worker script. So this is an entire worker. So it uses the service workers API, so it's very familiar JavaScript. And so what we do is this is how we we register an event handler. So we respond with something that returns a promise of a request, a response. So this is browser JavaScript. So what this code does is based on the URL, so this is using KV. So until KV existed, there was no way to have state associated with your edge application. So you could call back to something else, you could serve another resource, but you wouldn't be able to read or write data from our edge. So it was limited, the usage were limited to transforms. There was lots of very good use cases, and you could update data by redeploying a worker script, but that was onerous. So what this allows us to do is save read and write state from the edge. Predominantly, the current Workers KV product is geared towards the read-heavy workflow. So it is not write optimized. Writes are not fast as they could be around the world, but reads are fast. Sequential reads. We make use of our caching infrastructure to support that. So we don't have any pre-population feature, but as long as you're requesting it once every 30 seconds, it will always be within a few milliseconds of the edge. So it's very, very fast in that way. So what this does is, so it's just serving a creation time. And so it reads the URL that's fetched. And so every URL would have a distinct creation time. And if the value is null, meaning it hasn't been created yet, then we generate a creation time. And it says new response, that's incorrect. This should be new date. I copy and pasted it wrong. But so we create a new creation time, and then we put that create time into this key so that the next time this is called on the same URL, it would respond with the same creation time. So the functionality of this toy app is that each URL would report the time at which it was first accessed. So this is an example of a very simple but fully functional, except for the modular bug here, web application. Does this make sense to people? Are there confusing bits? And I guess there are some syntax that's confusing, and I'll get to that. The awaits, those are kind of mysterious. Yeah.
What's KV?
KV, great. So depending on who you ask, so it's a key value store.
Okay.
Yeah.
So this is all like, you say that it's storing the first time that it was, that URL was accessed. That's all in the browser, like in local store, or is that on your server?
This is on the edge.
Okay.
Mm-hmm. Yeah, so so it resembles local storage. We considered using the local storage API to implement this, but the local storage API is broken because it is slow. So the local storage API has no notion of async, which means even on a local machine, writing to your local file system can take milliseconds or tens of milliseconds or hundreds of milliseconds, and your whole page slows down in unexpected ways. So Google has a proposal to fix this with a built-in interface that's a key value store, and we won't adopt that for KV, at least in this instance, because we already have an API, and APIs are forever. But for future instances, and we'll talk about some of the things we're thinking about doing in the future, we're planning to adopt a more standard API. So we weren't big enough, like we don't have enough presence yet to say, hey, this is the new standard for what we're going to use. But if local storage had an async interface, that's what we would have used. So this looks a lot like local storage.
Are your writes replicated across your code?
Yes and no. So we'll get into the architecture. Right now, our writes go back to a cloud-backed storage. And that can be any one of the cloud providers that Cloudflare has agreements with for volume pricing. So there's no
out of this edge, then they get
yeah. So that's why writes are slow and the first reads are slow. So one of the challenges with using so in order to deploy a product fast, and then we'll get to some of the history. The initial goal was to provide configuration for workers. So giving people this use case, like to complete the workers product. What we'll build in the coming year will be more of the edge native storage that's fast writes and replication, and provides consistency properties. Good question.
And then you mentioned that kind of using a service worker API. Is that like a you're re-implementing the service worker API inside this product, or you're actually using like V8 or the browser?
So it's a it's an implementation of the service workers API. So for people who don't know, a service worker is like Gmail or any application creates a service worker that runs even if it's not connected to the internet. So it can do polling, it can do WebSockets, it kind of runs as an application on the page, and there's a well-defined API for how to write those and how they interact with the world. And a worker fit that model pretty well. And so the way that workers work, how we attach is the same way as like a service worker in a browser would work. So it looks very much like other JavaScript code.
Do you do like channels?
How do you mean?
So like in service where you can set up a channel with tabs to do two-way messaging communication. I'm assuming this is more just straight HTTP.
Yeah, so it's straight HTTP. There's no way to communicate between service workers outside of an HTTP request. Also, the lifetime of these workers is very short. So they're not permanently running. They have a max lifetime of 50 milliseconds and a max compute of, the max lifetime is 15 seconds. The max compute is 50 milliseconds. So it will linger around waiting for things. Other questions? Yeah.
What is value to be known there?
Also, good. Create time. I can't edit it. I won't do it. Thank you. So what I did is I copy pasted the Cloudflare example code, but it had all this highlighting that was like manual text colors. So I was like busy trying to copy the right colors around instead of like, oh. Yeah, so this would be creation time. That would be no.
One question. I didn't really work with Lambda since the beginning, but I know a big barrier was like authentication. How do you deal with that? And I know probably before it gets to this point, you handle that. Can you give like a high-level overview of how is that handled before it gets to this?
Yeah. So are you talking about client authentication?
Yeah. So basically, someone's making a request for making it right, saying I create time. I know it can be handled in a number of ways, like with the client making a request, or if it's just that right in general.
Yeah, so I'll talk about how we implement our security model for workers in the background, for KV in the background, and that we'll cover that side of it. Cloudflare has a product that I think is fantastic. It's called Cloudflare Access. Most of our products are really confusing because they just are what you're supposed to be doing. So you're like, I want to access this. Do you mean you want to use Cloudflare? But it's basically a wrapper around single sign-on and OAuth, so you can restrict. So any page that's accessed through Cloudflare, you can force it to have an identity provider. So when I log into any of my sites, I'm redirected through a Google authentication to provide OAuth access. So now that website, and I create my access control list on my Cloudflare based on the page. So I can say I want only Kloepper at cloudflare.com to be able to access this page. And there's about a dozen identity providers that we support. And that is a really strong solution for, and so my initial demo used that to get an identity for creating namespaces. And you can just protect, it's a really cool product. So it's our VPN killer.
What's that product?
Cloudflare Access. Yeah, and so it's, internally we're removing the VPNs from most things. So there's only a few holdouts where VPN is still used within Cloudflare. Everything is protected by Access. Other questions? But you're right, the authentication and building secrets into those containers is a challenging problem. Okay, so basic timeline. So this started just over a year ago. In January, just before my son was born, my third son, or my second son, third child, we had a meeting that was a brainstorming where we kind of talked about what we wanted to do. And we started out with a really, we wanted to do the edge consistent writes, big plans fast. And we kind of decided that what we really needed first was workers config, so complete the workers product. We needed a way to read it, like configuration values that could be updated or per user values. So we did a kickoff in London and then started planning, actual planning in Austin in April. By the end of April, we had the prototype done. And so this is my first time using workers, and I'm just so hooked because within 3 weeks we had an application that implemented most of what we have today outside of the nitty-gritty details that was deployed globally and anybody can use. So there are still people that are using this initial prototype, like internal at Cloudflare. They're running their websites off of static site that's there. So it was really cool how quickly that went. So then we had more refinement, added some stuff. By June, I concluded that we needed to rewrite in TypeScript because the size of the project was such that I was starting to see errors and was getting confusing and out of hand. My background is in typed programming, C#. I was on the C++ committee for a number of years, from 11 in Madrid to 14 in Issaquah. And so I really like types. I like back-end programming. And so being able to use JavaScript in a typed way, and Anders, who did C#, also wrote TypeScript. Like he created it, so it feels really good. And it's just a very thin, it's a type wrapper around JavaScript, and it transpiles, which I'm saying, to JavaScript. So you write TypeScript code, it looks a lot like JavaScript except with type annotations, and then it turns into JavaScript so that you can deploy it to the edge. So in September, we had the public announcement of what we were working on, and it was very popular. We were on front page of Hacker News for a day. We started the closed beta in October, and we just started the open beta. A lot of the heavy lifting work has to do with getting the API connected through our systems, doing billing work, making sure corner cases are covered, doing performance. And so we kind of went through this big to small to, oh, now we want to do Redis at the edge, to we just want read optimized KV store. And a lot of this has to do with trying something out, getting feedback, deciding on the complexity and refining. And so what we wanted to do is we want to do general availability, GA, as soon as possible. So we're starting with this limited set, and then we'll expand from there. And so that's kind of a bit of the timeline for this project. Any questions with that? So this is my logo slide. Do I have another one? Let's see, I have a minor. Okay, so this is my logo slide. So this I'll kind of walk through all the different pieces that we use, but if you're curious about particulars, ask more questions. So Visual Studio Code, I like Microsoft tools. Visual Studio Code is specifically for TypeScript. It works really well. I'm very pleased. TypeScript and ECMAScript. So I actually included both of these because a lot of the features that make the code possible are just JavaScript, latest JavaScript features, typed arrays, buffers, async, promises. Those are all just JavaScript features that are modern JavaScript, and those make programming very easy. Outside of C and C++, TypeScript and JavaScript are the easiest languages to manipulate binary information. In certain ways, it exceeds it because of you can have Indianness, and it's just very, they did a really good job. So any binary manipulation we do, I'm just very pleased. I can't create structures. That's the only limitation. So if I could create structs that map to binary like C, I'd be happy. So we use rollup JS instead of Webpack because most of the transpilation happens in TypeScript. Rollup does tree shaking to eliminate unused code paths, which is really important to me to compact the binary size so that it loads quickly on the edge. So right now, the whole script is about 40K, and so that loads pretty quickly. We have beefy servers, but still milliseconds are milliseconds. So what kind of makes this messy, and so why I said this is systems programming on the edge, is because a lot of what we're doing is binary file system type work. So we're building a file system, a KV file system on the edge that uses a cloud-backed object store. And so we're really doing a lot of systems programming type work, but we're using browser-side JavaScript code. So Node.js doesn't really support modern JavaScript libraries that the browser does. So you have to have polyfills to run them, and you can't run browser code on your desktop for unit tests very easily. So we have this dual system where we roll up JS, but in one path we're using Node and Jest and TS-lint on the development side to run our unit tests. But in production, we're running on V8, which is Cloudflare Workers. This is for error reporting, and React is for a demo app that I wrote. So these are only sort of used. But so this has caused a number of issues where so setting this system up took a few weeks of just like beating my head against the NPM wall. Because getting polyfills to work, getting the libraries to just not do the wrong thing, especially when versions were out of sync with the latest, it's just a headache. But once it works, it's great. And so one of the early things that I identified was that I needed to have very good unit test coverage in order to develop this, because actually deploying to the edge and running browser tests would be okay, but it'd be really slow. And it's hard to debug. The Workers platform is coming a long way, but it's still not mature in the sense of being able to trace it in production, and there's no way to get console.log from production yet. There's a preview service, which is fine, but it is slightly different environment. So something that's really cool, I think, about the Workers product is there's nothing Cloudflare specific or special that we're doing. Any of you could write this and deploy it on our edge, and it would work. So there's no Cloudflare internal interfaces we're using. We're just using commodity production workers. But we were pushing the envelopes of what we could do. So we hit, and so this is sort of like advanced dog food, we hit bugs before anyone else. And so that's why this was very difficult to use to do debugging and iteration in production. So I had a whole set of acceptance tests that we were on, but it was very important to be able to run things on my development machine. And even the whole end script, I can actually spin up locally, and it would connect to the cloud. So I could do traces where things were particularly problematic, like getting the authentication to the cloud backends and making sure that that protocol was done right. I oftentimes had to resort to Wireshark for what the heck's going on. Not oftentimes, a few times. That's worst case scenario. Questions about the ecosystem? Yes?
Did you say you were trying to run browser code in Node? And why?
So, so service workers are a particular interface that's like Node in the browser. So historically, browser code is event triggered, but service workers are persistently running. So it's sort of like Node, but in the browser, in the sense that it's running in the background. It can access files. It can, in certain ways. But you can't run that as a standalone application. And you can't, and unit tests have kind of use Node in the background secretly too. So there's a few libraries that are available on all browsers. Subtle Crypto is a cryptography API that's available in the browsers, but it's not available in Node, and it's actually different. Some of the buffering code is different between Node and browsers. And so most of the complexity had to do with, okay, what is a browser API versus Node? And so right now we actually use no Node packages in production. I'm just using browser libraries, which makes the binary really light. And so I use rollup to make sure that doesn't accidentally leak, because I don't actually bundle anything from the Node repository. But there's lots of Node libraries that are used as part of the development. And so because I have that distinction, I'm confident I'm not going to accidentally bloat the binary size. Does that answer your question? Sort of?
Kind of thing. I'll have to take your word for it. There's no way to run service workers outside of the browser.
There might be.
Never thought about that.
There might be. And again, I I could be completely ignorant of a lot because I'm not a web developer. And so there might be good ways to do this that I just have overlooked. And so I'd be really happy for feedback. Other questions? Yeah.
I've always got more.
Great.
You say that you use rollups for certain things. Have you tried any other libraries like compare at all?
I mean, so Webpack is the only other one, and it just makes things bigger. It's a lot more complicated. And I don't need it to do most of the things that it does. So Rollup did exactly what I wanted it to, and it did what I thought Webpack should do. It's like, oh, I just wanted it to do the thing and make things go away, and it did. And then I tried to use Webpack because people were using it. I'm like, this is a monster. It's really good if I was doing a full website because then it could minify and package a bunch of other content, which Rollup can do, but specifically because I was just stitching. So the way that the Workers runtime functions is that you upload a single script, and that's your worker. So I needed to bundle applications. And so I have, hundreds of files that all bundle into one deployed application. And so I needed to be able to bundle the code together, and that's why I needed something. And Rollup fit the bill. And Webpack, as far as I know, doesn't do tree shaking, which is really important to me.
It does. Yeah, just it was late to the party.
Okay, so it doesn't do tree shaking. Maybe it does now.
Yeah.
Yeah.
Webpack 4.
Yeah.
So again, like any time you're talking about JavaScript technologies, as long as your slides are made and you've used the technology within the last week, you're okay. But other than that, this is what we use, and we are out of date about 4 months ago. Other questions?
I think you had like WASM on an earlier slide.
Yes. So we don't use WASM, but our workers support WebAssembly. Okay. And so that will only increase. We've started to hire WebAssembly experts to build that out more. There's a lot of promise there. JavaScript inside of V8 is only, like, so if you do something in WebAssembly as opposed to JavaScript, you're like, WebAssembly is 1.3 times faster than closure compiled JavaScript in V8. So, but if you're doing type, there's certain places that express it better. Like people want to do Go in WebAssembly, but Go is just such a behemoth monster of like including the world that it just doesn't work yet. Any garbage collected language doesn't work well with WebAssembly.
Have you seen the Blazor stuff?
Mm-mm.
So yeah, that was another topic with they're compiling C# down in WASM. So
yeah, so I expect that this is going to be really important going forward, and so that's why we support both. That's one of the nice things about V8. But right now, JavaScript dominates, and so 5 years from now, WASM might be more important, but it's really nice that our worker runtime supports both.
So are you deploying, like, if you went and looked at your deployed file, it's human readable, I mean, it's probably uglified or minified JavaScript?
We actually recently changed from minified to unminified for improved clarity on the stack traces. So it goes from 25K to 40K, and it's a lot easier to see where the stack traces end up. And so it's still bundled, but it's unminified. Because there's no client ever sees this code. It's only deployed on our edge. So our developers could see it, our support engineers could see it, but so I'd like to go back to, I mentioned JavaScript. Does everybody know what async does? Okay, good. We have some yes and some no. That's great. Are people familiar with promises? Okay, mixed. Great. So a promise is a programming model where this function returns immediately. So it runs a couple of codes, and then it returns a value that's a promise. And a promise is a value that has a function that can be awaited. It can be thened. So it's basically, if you're familiar, if you've ever written closures in JavaScript, like callbacks, and you say create a callback function and then pass it in. And so this is .then and promises are a way to make that better by saying, you say .then, and then once something is complete, so it says await, but we could say .then and put everything in here in a like function that calls back when this is completed. So await is a syntax sugar to make it look like, so it pauses the whole stack and runs something else until this responds, because this is an IO bound operation. So async is a decorator for a function that allows await to be used, and it also changes the response of this to be a promise. So it's a way to handle concurrent programming or asynchronous programming. I would highly recommend reading up on await and async and promises in whatever language you are programming in, because they are very important. Especially with any distributed programming, any networking programming allows latency to be hidden very well. Okay, so this is a simplified description of how Workers KV functions. So we have the storage gateway worker is the primary script that gets uploaded. So before we had that like 4-line or 10-line script, that's a full worker. So our storage gateway worker is the same script, but it's more than 10 lines. And it has a couple of layers in it. This isn't exhaustive, but it kind of gives us the idea. So we have our web API layer, which is basically a JavaScript router. So different endpoints do different things. We run different code in response to them based on parameters in the URL, standard router, like HTTP mux stuff. The two consumers of that are api.cloudflare.com. So if you can read and write values from our API to set data in there, or other workers. So you can also read and write values from other edge workers. And this is the primary use case. So in the example earlier, it was another worker that was reading into this worker. So it was making a web request and it spun up another worker. So in the worst case, this path takes about 7 milliseconds. In the best case, it takes about 1 millisecond. And it's going between the same box. Again, that's too slow, and that will be fixed by combining processes. We have a thing called pipelining that will happen. Eventually, we'll get rid of and optimize the HTTP call away, so it's just doing RPC between them, and it will get down to the tens of microseconds range. So I said earlier that anyone could write this. So you could write this and deploy it, but it does a couple of things that are important. So we do AES 256 encryption on all the values that we store, and that key lives in configuration state that's with the worker. So we have no way from the storage gateway worker, none of that, the crypto keys are stored in this worker itself. They're all passed in as part of the request, so it's ephemeral. So authentication you were asking about earlier, this worker has a variable that's bound into it that's only able to be read by our edge machines. So it's encrypted when it goes out, and so only the edge machines can decrypt it. And then that allows the edge machines to inject a authentication header to the request that hits the storage gateway worker. That authentication header is the decryption key for the data that's stored both in our cache and in a backing service provider. So it's a pretty elegant model. No one has all the information necessary to decrypt it. Likewise, you can't access this without having a key that's contained by this. So indexing and encryption is handled. All that happens on the fly. So then there's the cache work. So this is what makes it fast, both from a development perspective, time to market, and from a performance perspective. So one of the first things that Cloudflare did as a company is a big web cache. Like that's still what we do. Like we cache huge chunks of the internet based on usage. People trust us with their HTTPS keys, and we can cache the raw content. Nick and I worked for Riverbed for a long time, and we tried to do this before HTTPS was really a thing, so it worked. But then HTTPS became more of a thing and it became harder to do. But as crazy as it sounds, people give Cloudflare their encryption keys so that we can serve content and access their origins. So, so we've been caching lots of content for a long time. So we make use of this cache. There's a cache API from Workers, so I can read and write values in my Colo cache. And we store the fetched values in this web cache, so any subsequent fetches are fast. And then we make it responsive by revalidating this cache in the background, as long as you make a request once every 30 seconds or so. And then there's the storage provider Glue, where we fetch your data from one of the storage providers. We only use one at the moment, but within the next quarter or two, we will be arbitrating between all of them. So we'll store it in backed up copies between multiples, and then on failure, switch to one or the other. Does this make sense? Do you guys have questions?
You encrypt it when it goes into those storage devices.
Absolutely, yeah. So the encryption happens when the value comes in, and from this point down, it's encrypted.
So could I decrypt it, or like can I provide Cloudflare my keys so I can decrypt it on my back end out of the storage mechanism?
So you could you could encrypt keys before you wrote them, but right now, like, there's no way that you can own this key. There's nothing about the storage gateway worker that means that it has to be here, but how we built the product. Only, actually, anyone who has a Google email account could create an instance of like a direct token, and then you would own the key, and this would never remember it. So we do support, like, we want to provide the extension for customer managed keys. Most people don't want to do that. That's a good question.
Well, what's their story for getting data out of the cloud? If they don't have the keys, what's their story for getting data out of the cloud?
So the data is accessed entirely from Workers.
So they would also be getting, the backend, the product owner would also be getting the data using a worker.
Yeah, so they either get it, like it runs in a worker, and that's the primary use case. Or, I mean, you could pull your data from the API, which accesses this directly. If we had this built when we were building it, then we would have written this as a worker. But we didn't, so we didn't.
Do you have payload limits on the value?
That's a good question. Right now, our payload limits are 2 megabytes. We can go more than that. The only challenge, so what we have to complete implementing is blocked streaming encryption. Otherwise, we have to load the whole value, because the way that AES is implemented in the browser in crypto is it's like you need to put that as the whole buffer. So we have code that does block streaming encryption. We just haven't fully vetted it. And so you would be able to do arbitrarily sized values. So that's probably one of the impending pieces of work, is to remove the 2 megabyte value limit, and also to allow metadata to be stored. So you could just have a static website storage very easily.
Taking on that a little bit. So what is image resizing like a common use case?
That's a very good question. Yes. We have internal image resizing. So there's this, so Workers is powerful enough that we're rebuilding. The goal is to rebuild most of our product using Workers, the Cloudflare product. And so we call it first-party Workers. That's Workers that perform traditional operations. So we have image resizing as part of our features. And so there's a team in London, the Speed team, that is rebuilding that using Workers. So image resizing is definitely a use case.
And then on that, I think you said I just have to upload one file for a worker. And so I can use whatever like NPM libraries I want as long as I can compile it out.
Yeah, and so lots of people do that. I mean, that's very common. I mentioned there's lots of performance benefits we still have to put into Workers runtime. One of those is eliminating so you can do an import directly instead of having to bundle it for the common NPM libraries.
Other questions? Let's see.
So with the, sorry.
Yeah, go ahead.
With the multiple cloud providers, for the storage, would I be able to limit where my data goes? If I don't want my data to go to, I don't know, Backblaze, I don't like those guys.
Yeah,
Or,
jerks.
you know, wherever, they're not jerks.
No, they're not. No.
But, you know, for instance, I don't want it to go to IBM because I don't like them or
Mhm.
whatever. Can I say, please don't put my data in this place?
So not as part of the KV product. So let's see, I think just, yeah, what's next in questions? This is what we're talking about now, but we're on this slide. So what's next in questions? So one notion of a future product that we're probably going to build is a, basically an object storage optimizer speeder that allows you to control placement of your data across cloud storage providers and be able to move it from one to another transparently to give a consistent interface. And so that would be more along the lines of that product, because that's definitely something that people ask. And they'd actually probably want to be more specific than one provider or another. They're like, I just want it in Germany. I can't have this data leave Germany. And so that would be, if you could do that, that would be people would be happy. Because vendor lock-in with cloud providers is very not good. And so we in fact, we have a bandwidth alliance, which allows you to have free egress from most of these if you're a Cloudflare customer. And so Cloudflare, because we're directly peered with their colos, and then because of Nick's team, we can pull that data from across our network. So it goes different. We can route and to get the data out at the colo we're peered at.
So these aren't bring your own cloud. These are partners that you have. Like, just if I have a Google Cloud account, I'm not giving you my credentials to store my stuff.
Yeah.
Okay.
These are just examples of cloud providers that, yeah. But that is something that we want to potentially support in the future, is that you would give us your cloud credentials if you wanted to, and we would provide a wrapper around your data to make it very fast on our edge everywhere. And you would actually take ownership of those objects at the nodes, so it'd be fast, high frequency writes. So right now, most providers, you can only update an object once per second, and so we would eliminate that barrier. We would provide consistent transactions, so e-tags, uniformly across all the providers, and then we could replicate it to all of them. So that way you could spin up your code in any provider that you wanted.
That's where my question about keys before was.
Okay.
You're storing my data in my cloud storage accounts. I might want to have a backend process.
Yeah, that makes sense. No, we're not.
Gotcha. Okay. And then are you honoring like data sovereignty requirements around the globe? Like you mentioned Germany, right? Like
None of that's built into the product right now.
okay.
That was my question, like the GDPR, are you doing any like retention products or features?
No, not as part of this. All of the code right now is stored in the US. Not the code, the data is stored in the US right now. So other places we're going, we're trying to figure out how to integrate storage better. So we might build different sorts of value stores. So maybe that wouldn't be key value. And we're also working on creating workers that are like nano services, where your code and your data is locally resident and only one place in the world, and that would move around to be close to either the resources that it's using or the clients that are accessing it. And so those are some of the cool things that we're working on that maybe I can talk about next year. So any other questions, feel free to come and get me afterwards, but thank you very much.